Here's another reflection on how we figured out how warm it is. That seems kind of an obvious thing. You just use a temperature gauge, thermometer of some sort, and very intelligent people of the past have figured out a way to see how high the mercury rises in the thermometer, and that's related to the temperature. There's a direct relationship between temperature of mercury and its expansion, which causes it to move up the thermometer tube there. It's a fantastic idea. Now, when we deal with, say, a hot summer, especially here in Sacramento, it gets quite warm in the summer. I love it. But anyway, they want to tell us sometimes, say, okay, they'll tell you it's 105 degrees, okay, which is plenty warm. But what they don't tell you sometimes is that they've gotten that temperature by a temperature gauge, a thermometer, that's in the shade. However, we spend a lot of time in the sun, especially in Sacramento. It's very sunny. There aren't very many clouds in the winter. It doesn't rain hardly all winter. I mean, if you've been following the news, you know about the fires up here. Well, not just Northern California, Southern California. It doesn't rain that much in California in the summer. It hardly rains at all. And even Southern California, it hardly rains all year round. Okay, so it's kind of a dry land in a lot of ways. At any rate, I think they're underestimating how hot it truly is. I remember when they finally started talking about how truly hot it was inside of a car. Right, okay, you think it's 105 degrees? Well, maybe it's 105 degrees in a car. No, it's much, much hotter inside the car as the car gets baked by repeated sun rays. The pressure goes up in there and pushes the temperature up along with it. You know, PV equals nRT. At any rate, they need to update the temperature perspective. Okay, they need to tell you what the temperature is in the sun more often, especially a place like Sacramento where it's so sunny. You're experiencing the weather in the sun more than you are in the shade. Now, I know that there is a challenge with determining the temperature in the sun with the temperature gauge, because the temperature gauge very well may melt, as my professor Jennifer Henry pointed out. But what I'm trying to emphasize is that when you're telling people the temperature in the shade, that's not what they're experiencing on a regular basis. When they're walking around, they're on that blacktop, maybe we need another temperature gauge or formula to figure out what the temperature's on the blacktop, because we know that's hotter, right? On the grass, it could be a little cooler. So I'd like to see meteorology expand to where it tells you more localized temperatures. Okay, you can give me the temperature in the shade is 105. Okay, give me the temperature in the sun by some sort of calculation. We know normally it's about 15 to 20 degrees warmer in the sun than it is in the shade. Now, how I figured that out, first of all, was by watching tennis matches. The tennis matches will show a temperature gauge that's in the sun, and they were showing, I think, Indian Wells tennis tournament one time, and they showed the temperature in the sun was about 125 degrees. And I play tennis. I played tennis when they said it was 95, 100 degrees. I'm like, no, it's hotter than that. What I'm feeling out here is about 115 degrees. And you need to know that as a tennis player to understand the type of hydration that you need, the type of ice that you need to be putting on yourself, the way to cool down. Is here we're coming up to the Australian Open. It's going to be extraordinarily hot. And they've developed these ice vests and cooling towels and so forth to help the players, but I think they're going to also need some cool water dripped on them, right? Not cold, because that'll put you in shock or something. Just like I don't want to drink super cold water. If I'm standing 125 degrees and I try to drink 40-degree water, my insides are not going to appreciate that. I need something more around, 60. And I can drink it, right? You've probably experienced that. At any rate, I think we need to, become more specific about our temperature determination, especially this high temperature. So in Sacramento, for instance, if you were to do this, you'd have some days where the high temperature, the temperature in the sun might be 120 degrees. And then we know that at night, the temperature goes down to sometimes in the upper 50s, 58. So we're talking about The birds are tweeting pretty good. We're talking about a good, what is that, 42 plus 20, 62 degree difference, just to have you understand the experience that you're having a little bit better. And it really shocked me coming from the East Coast, where the temperature difference is not that great between the day and the night. If it's 90 degrees during the day with all that humidity, at night you might not see any lower than 65. So, and then, okay, it's 90 degrees in the sun, in the shade, say in Washington, D.C. In the sun, it's probably about, 105. It's cloudier there, it's muggier there. Okay, so I want to see that calculation of determining the temperature in the sun. Okay, maybe you want to average the temperature when you're in a cloudy condition versus the temperature that you experience in a sunnier condition. That all needs to be put into a formula, so to speak. It might not even be completely mathematical. Some of it is mathematical, some of it may just be qualitative. Okay. At any rate, let's see if we can get that advancement in meteorology going.